Bismillahirrahmanirrahim. Assalamualaikum. So this video is the video for the example 3 from the induction motor slides. Okay, in the previous video I've explained on example 1 whereby the induction motor is star or Y connected. So for example 3, what's the difference for if the induction motor is delta connected? So we go straight to the question. Example 3, you can refer to your slide. A 3-phase delta connected, 415 volt, 50 Hz, 6 poles, has the equivalent circuit parameters as below. So the question gives you stator resistance, rotor resistance, stator inductance, rotor inductance, and magnetization reactance. Well, the RC is infinity, and that we can assume that your RC is open circuit, yeah. Okay, so before we start, let's list down the given information first. Okay, number 1 is it's a delta connected induction motor. So please write down the relation for voltage and current. V phase, I phase, I line, I phase for delta first. So for delta, we know that V line equal to V phase, but the I line is equals to square root 3 magnitude of I phase. Angle of I phase you must minus with 30. And then it's delta, and then it's 415. Okay, so 415. Okay, 415 is the terminal voltage, obviously, but is it a phase or line voltage? So since it's not stated, so we assume that it is a line voltage. So again, another thing is the angle of 415 is not given, so we assume that it's the magnitude of the V line, 415. And then frequency is 50 Hz. Number of pole is 6. Okay. Next, we sketch the equivalent circuit of the induction motor. Okay. So I'll sketch it here. So since your RC is open, we just draw it like that, or you can just draw straight downward, no problem. Okay, so stator resistance 0.07 ohm, rotor resistance 0.065. So this is R2 over S, so make sure you put over S here. This is R1, yeah. X1J, X1 is 0.25J ohm, and the next 2J is, or X rotor is 0.25 as well. And finally, your XM is J 8.35 XM. So this is your V phase or V terminal phase, I1 phase, I0 phase, and I2 phase. Alright. So what are the other given information? The full load speed is measured at 950 RPM. So full load speed, it's not stated whether it's synchronized or motor speed, right? But usually the given speed is actually an R, or rotor speed or motor speed. Why? Because okay, logically we can measure using any equipment. We can measure the speed of your rotating rotor, okay, that we can physically see. But while on the other hand, for synchronized speed, you cannot use any tools to measure it. Okay, usually you will find it out through calculation. So usually the given one is the motor or rotor speed. Okay, measured because it's stated there measured. Okay, we cannot measure synchronized or magnetic field speed because we cannot see the magnetic field, right? So actually the word measured referring to the rotating rotor. Okay, and then the rotational loss are measured at 900 watt. Only one loss is given, that is P rotational loss, given as 900 watt. Okay, so what are the questions? Number 1, find the slip of the motor. Alright, slip. Number 1, the question asks you to find slip. Not slip speed, but slip. So the formula for slip, you may refer to your slide. And S minus Nm divided by Ns. Okay, you have your Nm, but you don't have your Ns, right? So you need to find your Ns according to formula 120F over P, that is 120 times 50 over 6. That gives you 1000, yeah, 1000 RPM. So now you can find your S, that is 1000 minus 950 over 1000. It gives you slip of 0.05. Done. Number 2. Remember, slip doesn't have unit. Okay, because RPM over RPM, you cancel out RPM, so it's a ratio actually. Okay, so number 2, stator line current. So which of these 3 current is the stator current? Number 1, because remember our input for induction motor goes into stator, output converted at rotating rotor. Okay, so input enters through stator. So I1 phase is your stator phase current. But the question asks for stator line current. Okay, never mind. Okay, or you can check from the beginning. So it's a delta connected, so I phase is not equal to your I line, right? So I1 phase will not be the same as I1 line. So what we do is we find I1 phase first, then we convert into I1 line. So to find I1 phase, okay, see area, I1 phase equal to I0 phase plus I2 phase. So I0 phase in this case equals to V phase divided by, since we don't have RC, so we are only left with XMG lah. Okay, plus V phase over R1 plus X1G plus X2G plus R2 over S. Okay, this V phase, these two V phase, okay. Look, the given information is the V line. So we have to check for delta. Is V phase equal to V line? Yes. So we can simply take 415 as your V phase because it's equal to your V line. So V phase equal to 415. But that is the magnitude lah. Okay, but since since the angle of the V line is not given, so we assume the angle of V phase is at 0 degree. So now you can calculate. Okay, so we have here 415 at angle of 0 divided by XMJ is 8.35J plus 415 angle 0 divided by your R1 is 0.07 plus 0.25J plus 0.25J plus 0.06 over S, that is 0.065 over your S from the previous question, 0.05. Close bracket. So this will give you I naught phase. Please write down the final answer for I naught phase in polar, I2 phase in polar, and finally I1 phase in polar, because at the end you're going to need the magnitude of I2 phase to make some calculation. Okay, so the answer is 49.7 at angle of minus 90 and 284.56 at angle of negative 20. And lastly, you get your I1 phase as 305.19 angle negative 28.85 ampere. So that is your I1 phase, the magnitude with the angle. Since the question asks for I1 line, stator line current, so use this equation. Okay, that is I1 line equal to square root 3 times magnitude of I1 phase, and the angle, you take the angle of I1 phase, have to minus with 30. So that will give you final answer of 528.61 at angle of negative 58.85 ampere. Okay, so that's the answer for question 2, stator line current. So next we go to rotor copper loss. Okay, again, for any power or losses that you are asked to calculate, if you can calculate using formula, please use the formula. If not, then you need to consider whether you can find it using plus or minus from the power flow. Okay, for example, now the question asks for rotor copper loss. So does rotor copper loss has its own formula? PRCL. Yes, it's the loss at the rotor resistance or R2. So 3I2 phase squared R2. Okay, that is 3 times magnitude of I2 phase. Okay, magnitude of I2 phase. Why magnitude only? Because we are calculating power. Power don't have any angle. So I2 phase is this one, 284.56. So 284.56 times R2 from the question, 0.065. It will give you a total of 15.79 kilowatt. Okay, number 4 is air gap, not air gap power, but air gap torque. Okay, don't worry. Okay, we know that P air gap, the formula for P air gap is induced torque times omega s, or 3I2 phase squared R2 over S. So the question asks for air gap torque. So when in this case, air gap torque, the one that is related to air gap power is the induced torque. So we can also call this induced torque as air gap torque. Yeah. Okay, in other words, you need to find your air gap and omega s for you to be able to find air gap torque. Okay, so P air gap. P air gap has another formula. So can we calculate this? Can we use this formula to calculate air gap power? Yes, we have all these values, right? So calculate first your P air gap. 3 I to phase just now is 284.56 squared over R2 0.065 over your S is 0.05 just now. So the answer is 315.8 kilowatt. So now we have P air gap. Next we need to find your omega s. Omega s we can find it from NS. So what's the relation between NS and omega s? So omega s equals to NS times 2 pi over 60. So your N just now is, okay, NS in RPM, yeah, omega s in radian per second. So your NS just now is calculated as 1000 RPM. So 1000 times 2 pi over 60, you get okay, I forgot to bring my calculator with me, so you may calculate this yourself later. So your answer will be in radian per second. Okay, but I have the answer for air gap torque. It's okay, you can calculate it, just a simple calculation. Okay, so from here air gap torque equals to P air gap over omega s. So your P air gap is 315.8 kilo divided by whatever your omega s is here. So the answer for air gap torque is 3015.66 Newton meter. Okay, done. Next is air gap torque done, output power. Okay, so any power, if you can find it using formula, use formula. If not, use the plus minus from your power flow. So P out, yes, it has a formula that is only one, output torque or load torque times omega m. But we don't know, we can find omega m, but we don't know your load torque. So so we have no choice but to use the power flow diagram. So just sketch P air gap, P converted. Here you have P stator copper loss, P core loss, P rotor copper loss, P mechanical loss, and P stray loss. Then we check which power that we already have the value. For example, from the question given is the rotational loss given as 900. So okay, mechanical loss is divided into two, rotational loss and friction and windage loss. So rotational loss is given as 900 watt. So this is 900 watt. Okay, for these three, 1, 2, 3, if it's not given from the question, you don't have to calculate. So this one we assume as 0, 0, 0. Okay. PI gap from the question 315.8 K. Yes, we do have PI gap. PRCL from question 3. Yes, we do have PRCL 15.79. Okay. So we want to find at this stage. Can we find P out already? If you want to use P out equal to P converted minus P rotational loss, yes, we can, but we have to calculate first your P converted. Okay, that is equal to PI gap minus PRCL. Okay, let me show you. P out can be P converted minus P rotational loss. Okay, actually minus this and this, but it's 0, so we are only left with this, but we don't know yet your P converted. Okay, but we can find it P converted using PI gap equal minus PRCL equal to P converted. Okay, so P converted we substitute with P converted equal to PI gap minus PRCL. Or in other words, you can, in overall you can see that PI gap minus 1, 2 equals to P out. PI gap minus PRCL minus P rotational loss. This minus this minus this minus 0 equal to P out. So PI gap is 315.8 K minus PRCL is 15.79 K minus P rotational loss 900. That will give you 299.11 kilowatt P out. Okay, done. So that's your P out, output power. So last one is the overall efficiency. Okay. For overall efficiency, the general formula is P out over P in. Times 100. So we do know your P out from the previous question, but we need to find your P in. So P in, does P in has its own formula? Yes, 3 VT phase I1 phase cos theta. Can we get P in? Can we calculate P in using this formula? VT phase, yes, we know the value. I1 phase, yes. Cos theta, angle of VT phase minus angle of I1 phase. Yes, we do have all those values. So just calculate 3 times VT phase. Just take the angle, yeah, because we are calculating real power. So angle of VT phase is 415. For 15, I1 phase, angle of I1 phase is 305.19. Okay. And then cos, your theta is angle of VT phase minus angle of I1 phase. So angle of VT phase is 0. So 0 minus angle of I1 phase, this one, negative 28.85. My negative 28.85. So answer is 232.81K. So now you can calculate your efficiency. Your P out from the previous question is 299.11K. So 299.11K divided by 332.81K times 100. So you get 90.09%. So that's all for example 3. So the only thing I want to highlight here is the difference between Y and delta is that your V phase will be equal to your V line. Okay, so if your V line given as 415, so angle of V phase also 415, but since the question didn't give you the angle of V line, so we assume V phase at 0. Okay, so unlike Y connected where we need to convert from V line to V phase. Okay, please refer to the previous video. And the other difference is I1 phase is no longer equal to I1 line. So if the question asks for I1 line, you need to use this formula. Square root 3 I1 phase, angle of I1 phase minus 30. So that is your I1 line. Okay, that's all. Thank you.